All right, next we're going to learn about what happens when you take an acid and a base and you combine them and they have a chemical reaction. And these are called neutralization reactions. All right, so let's take a look at a real life neutralization reaction that can happen between hydrochloric acid and sodium hydroxide. First of all, we got to be able to write those, which you've learned how to do, but it's been a long time since we've done some formula writing. So let's remember hydrochloric acid. Do you remember any of your naming rules there? That hydro and the chloric means that we're going off of the periodic table that comes from chloride. So the hydro is H, chloric comes from chloride, HCl, hydrogen's +1, Cl is -1, so it's just HCl 1-to-1. Isn't that nice? And then sodium hydroxide, I look up sodium, that's +1. Hydroxide, ooh, that's one of my polyatomic ions on my ion sheet. I look up that, that's OH and it's -1. Oh, sodium's +1, OH is -1. That works out nicely. So I write it like that, NaOH. Okay, so now we're going to take that, and we're going to write it in equation format, okay? As it turns out, both those things are aqueous. How do I know? I can look on my solubility rules. If I look it up, Cl is always aqueous unless it's with a couple of different things, but hydrogen is not that. So HCl is aqueous. And if I look up anything with the alkali metals, which is Na, is always going to be soluble, which is aqueous. So that's how I knew those AQs went there. And then, of course, I put my arrow in. Now, think back. We learned that there were, I think, 5 different kinds of reactions, right? There was synthesis, decomposition, single replacement, double replacement, and combustion. So can you figure out what kind of reaction this actually is? I have 2 aqueous things, and they're both compounds, right? They're both like attached here. There's an H attached to Cl. Here's an Na attached to OH. We have like 2 compounds, both aqueous. That's going to be a double replacement reaction. Okay, so as it turns out, neutralization reactions are just a type of a double replacement reaction. We've seen those before. Remember, in a double replacement reaction, like the positive things swap places, right? So the H and the Na is going to swap places. That's it. So let's take a look at how that would go. If the H and the Na swap places, that means that the Na is now going to be connected to the Cl, right? Na is +1, Cl is -1, so that's it. What state of matter is that going to be? If I look up on my solubility rules, anything with Na is always soluble, so that's going to be aqueous, okay? And so now that also means that our H, right, our H is now going to be buddied up with this OH. So we could write that out as HOH, except for some of you might already be seeing where this is going. HOH is actually just water, right, which we would write as H2O. Okay, what state of matter is water? Water is a liquid. There you go, okay? So there we go. We've got it all written out. And then we want to just check to make sure if it's balanced, of course. So let's see. I've got 1 H here, but I've also got 1 H here. So I have 2 H's on the left, and I've got 2 H's on the right. I've got 1 O here, 1 O here. I've got 1 Cl here, 1 Cl here, 1 Na, 1 Na. So as it turns out, that is already balanced as written. Excellent. Why do you think these are called neutralization reactions, do you think? Well, if you look at our products, what is something that's made? Water is made. And you might remember from like our last lecture that water is neutral on the pH scale, right? Water has a pH of 7, which is what we call neutral. Okay, so with all neutralization reactions, they all produce water. Okay, so if you take an acid and a base together, you make water. Pretty cool, huh? And in this case, we make water and NaCl. What's NaCl again? Salt. So you take this acid, which you would never be able to drink, right? You take a base, which you would never be able to drink, and you combine them, and you basically get salty water. Pretty cool, huh? So those are neutralization reactions. You always get some kind of product and water. Those are your 2 things that are made. Okay, let's see another one. We've got phosphorus acid and calcium hydroxide. Back to our formulas here. Phosphorus acid, okay, there's no hydro and it ends in OUS. Okay, so we're going to be on our polyatomic ion sheet. OUS comes from ite. So looking at phosphite, so that's PO3 with a charge of -3. We know that acids start with H, so how many H's will that take to balance out that PO3? It's going to take 3 of them, okay? So there's our formula, H3PO3. And now calcium hydroxide. We look up calcium, it's in group 2, so it's +2. Hydroxide, again, is on our polyatomic ion sheet. If you've forgotten since a couple minutes ago, it is -1. So Ca and OH don't balance each other out perfectly, do they? You've got Ca that's +2 and OH that's -1, which means you're going to need more OHs, right? You're going to need 2 OHs. And how do we write that? We're going to use our parentheses. So this is how we would write that out. Again, this is a review, but I know it's been a while, so always good to talk it through. So let's put that now into kind of an equation form there. Those are both aqueous as well. Some of these things might not necessarily be on your solubility sheet, and on the bottom of it, it says they're all solid unless otherwise noted by your teacher. And here's my note to you. Any single acid or base that we give you in a neutralization reaction is aqueous, okay? That means it's already been dissolved. And so we would never give you anything that's some kind of solid or anything else. So you can just always assume that your acids and bases are aqueous that we're giving you, all right? And so now we're going to do our double replacement reaction where our H and our Ca are going to switch places, okay? So now our Ca is going to be with PO3. Ca is +2 and PO3 is -3. We have a +2 and a -3. How do 2 and 3 ever equal each other? We make them a 6, right? So this is where you can do your crisscross applesauce, okay, to help you out if this kind of is difficult for you as it can be for some people. And so we're going to need 3 Cas and 2 PO3s. And so that's how we would write that, of course, using our parentheses to show that this 2 applies to the PO3 and not just the P or not just the O, right? So now that's our Ca3, PO3 2, okay? And now our H is going to be buddied up with the OH. Now I know there's like a subscript over here of a 2. Don't worry about that. We're just looking, and there's a subscript over here of a 3. Don't worry about that. Just think about H and OH, okay? H +1, OH -1. Those go together evenly, right? And we would write that as H2O, +1, -1, boom. And of course, H2O is a liquid, and yep. All right. So there we go. Now, lastly, we're going to check here for balancing. This one's going to be a little bit harder to balance. There's lots of H's, there's lots of O's. I would highly suggest you leave those for the end because they're going to be the hardest because there's an H here and an H here and an O here and an O here and like, oh. So start with something easy, like start with the calcium, okay? I've got 1 calcium here and 3 here. Oh, okay, so how would I fix that? I'm going to need to add a 3. So I'm going to add a coefficient of a 3 right here. All right, so that fixes my Cas. Now, next I would go to any type of polyatomic ion, like my PO3s. Here I have 1 PO3 cluster. Here I have, with a subscript of 2, I have 2 PO3 clusters. Okay, so if I have 2 PO3 clusters over here, I'm going to need 2 over here, which means I'm going to need to add a coefficient of 2 on the left. There we go. All right, so let's just start with H's and O's now. Let's count up to H. I've got 2 times 3, 6 H's here, okay? This H is times by 2, so I've got 2, but the whole thing is times by 3. So this is 3 times 2, this is 6. So I got 6 from here and 6 from here, okay? So I've got 12 H's on the left. So what would I need to put right here to make it a 12? What times 2 is 12? 6. So there we go. 6 times 2 is 12. Boom. And now we can go back and double check our O's, see if they're balanced. I have 2 times 3, 6 O's here. 3 times 2, 6 O's here. 6 plus 6 is 12. Okay, so let's check it out. 12 O's on the left. I have 3 times 2, which is 6, plus 6 times 1, which is 6. 6 plus 6 is 12. Ah, my O's cancel out. All balanced. Great. I'm done with my coefficients. Good to go. So just to summarize here, neutralization reactions take place between an acid and a base. They are just a type of double replacement reactions. It's when you have 2 aqueous solutions that are mixed. Products are always going to be something plus water, and you all will need to be able to write out the formulas, write out the products, and balance them.